All right. Let's do it. Okay, so this one, how do we solve this thing? Well, what we do is these are the ones you have to graph. So this is the section we're doing today. We just started it last time. I hope you looked at that YouTube. That's for your benefit. You'll really benefit greatly if you look at those YouTube studies show. If you just glance at that YouTube, spend a little bit of time, we do the actual thing, it'll be way easier for you. So I hope you're doing that. So YouTube, what do we do? Well, it says maximize this subject to that. So there's one thing we're going to maximize and a bunch of other stuff that it's subject to. So what we do is we take the stuff it's subject to. Did we do one of these last time? No, we just did the plug in the points at the end, huh? And I ran out of time for the graphing, yeah. So basically what you do is you graph all of this stuff. And then at the very end, you plug corners. Once you have the graph, you plug corners into this guy. That's basically the game plan. So the game plan is graph the other things, get a picture, you're going to have a shape, you're going to have some corners, find the corners and plug them into the top one and take the highest, take the maximum. That's the game plan. These are super long. They take a long time. It's called linear programming. Here we go. So I'm going to graph. Let's take this first equation. How do I graph 2x plus 3y less than or equal to 12? What do I do? Get y by itself. Very good. That's the first step in graphing. Get y by itself. Grab that 2x, jump it over. Did a bunch of those yesterday. Oh, I had the dates all messed up for the homework, didn't I? Did you notice that? Somebody came by and told me. Thanks for that. I fixed it. So 7.1 was supposed to be due today, but since I messed up, I put it off till tomorrow in case that messed you up. So it's due tomorrow, class time. What's class time? 1:30? So 7.1 is due tomorrow now. I just fixed it 15 minutes ago. 7.2 and 7.3 are due on Tuesday at class time. Yeah. It's fixed now. So 7.1, I put it off till tomorrow in case it messed you up that I didn't have the right date there. All right, so anyway, get the y alone. Negative 2x plus 12. Good. Now what? Divide by the 3. Do I turn the symbol? Flip the symbol? When do you flip the symbol? When you divide by negative. If I put a negative down here, then I flip, but I did not, so I don't flip. Okay, so there's the first equation. Let's get the second. Let's get the second equation. So that one's 2x plus y less than or equal to 8. Same thing, jump the 2x over. Y less than or equal to minus 2x plus 8. So we get y alone for both equations, and then we graph them, right? You guys got that copy down? I'll go to a fresh screen here. If I can find it. There it is. Okay, so for this first equation, it's y less than or equal to, what is it, minus 2/3 x plus 4. Did I have that right? Minus 2/3 x plus 4, yeah. And the second equation is y less than or equal to minus 2x plus 8. All right, let's go to the graph. Now, when we do the graph, really all you need is the first quadrant, upper right-hand corner. You don't need the whole graph like they're showing. Why? Because it says x and y greater than or equal to 0, huh? That just means first quadrant. X greater than 0 is right, y greater than 0 is above, so upper right. Okay, so I don't have to do anything else with those. Those just mean upper right. That's all those mean. They're just saying, hey, upper right. That'll be on every one of these problems. So just know it's upper right. Just do the other stuff. Okay, so how do I graph this first one? Here's a couple of things you could do. Why don't we, what you could do, I think it'll be easiest, let's graph it on our graphing calculator. You guys have your graphing calculators with you, right? Let's just put this in. This will be y1. This will be y2. Let's just put them on our graphing calculators and hit the graph button and see what we've got. So let's do that. So I'm going to put that into my graphing calculator, show you what I've got. Let's see if I can write this a little neater. Minus 2/3 x. There we go. So yeah, put it into your graphing calculator. Make your window at first go 0 to like 20, 0 to 20. So you know what I mean? This is x min, x max, y min, y max. So make your window go 0 to 20. 0 to 20 is a good idea. Actually, why don't you do 10? Do 0, 10, 0, 10. Just start out there. And if you can see everything you need, great. If you need more space, make it bigger. 0, 10, 0, 10 will work. So I'm going to go 0, 10, 0, 10. Don't worry about the scale. Doesn't matter at all. Graph generally on my screen here, it's kind of like this, and the second one is like this. Okay, so getting something like that. I just drew a general, nothing specific, but generally it looks like that, doesn't it? One of the lines starts higher up and comes more down. The other one starts lower and goes further to the right. Sort of like that. It doesn't have to be real exact. Good so far? Now, there's going to be shading. Shading is going to be super easy. Even though we did that hard section on shading and everything, this will be super easy. All you got to do to figure out the shading is look at what it's saying. What is it saying? Less, less. So all the shading is the area that's less than both. So the less is more close to 0, greater's out there. So what's the area less? It's right in here. Does that make sense? If it said greater, it would be the outer region outside. So it's one or the other. All these problems, it'll be one or the other. It's either the very inside or it's the very outside. It's never these in-between sections. That makes sense? It's either for greater, it's the very outside. For less, it's very inside. Why? Because that's the region less than both lines. That's the region of overlap shading between both lines, right? If I took the time, I don't know if it's worth the time. If I took the time to do both shadings and find out where the overlap, remember that's what we were doing 2 days ago? I would like do the first line. I'd say, okay, first line, here's all the stuff less than the first line, right, below. And then if I took the second line and went, okay, and here's all the stuff less than the second line. So where do the two shadings overlap? See what we would get? That very inside. So you don't have to mess with it. Every time it's going to work out that way. You can just save some time. The overlap for two less thans is going to be the inner region every time. Okay, so I'll just say here it is, the inner region. That's the area less than both lines. Less than, less than. Okay, that's what's called, that little region. It's a shape. Kind of look at it like a shape. Let me shade it in for us. This is a specific shape we're looking at. That's called the shaded region is called the feasible region, feasible set, feasible region. Feasible, what does feasible mean? Doable, allowable, it's possible, right? Like it's feasible, you can get a good grade in this class. We still have one more exam and the final, lots of points. It's feasible, it's possible. That's the feasible region. That's the zone. Anything in this shaded zone is allowable, is feasible by those inequalities. They will satisfy there. In a minute, well, maybe 20 minutes or half an hour, we'll get to some real life ones, and we'll say, hey, anything in that region fits the reality we're looking at. So that's all possible. Now, we don't just want what's possible. That's all the possible region. We want what's best. We want the best possible answer. In a minute, this will be profit or cost with the maximum profit, lowest cost, something like that. How do we find that? Well, it's going to be at one of these corners. One of the corners, because that's the outermost, one way or the other, is going to be the best answer. It's always a corner. I'm not going to mathematically prove it. I don't even know. Oh, yeah, I do know how. But anyway, it's complex. I'm not going to mess with it right now. I'm just going to tell you, it's always the case. It's one of the corners. And by the way, it's not 0, 0. It's going to be one of those corners is the best answer. Everything, like even the dots in here, are possible, are allowable, are feasible. But they're not going to be the best answer. They're not going to be the highest or the highest profit or lowest cost. What are we trying to do? Maximum. This might be like a profit function. We want to know, how can business make the maximum profit? It's going to be at one of those corners of the feasible region. So therefore you just go by and find the coordinates of all of those corners. So how do you find this right here? That's where the two lines intersect, huh? Remember how to do that in your calculator? You have them on your graphing calculator, right? So to find that one, you just hit second, calc, and then choose intersect, and hit enter, enter, enter 3 times. So let's do that. And we'll get ourselves a happy little answer. Second calc, intersect, enter. I got 3, 2. Did y'all get 3, 2? 3, 2 for that. So that's the intersection of the two lines. Get that one off your calculator, 3, 2. Okay, how do I get, let's say, this one right here? Now that one is hitting an axis line, isn't it? It's hitting one of the grid lines. It's not floating out in the middle like this 3, 2 one was. It's sitting on the left edge. It's sitting on a grid line. Therefore, I know one of its coordinates already, right? That dot is over 0, isn't it? Up, I don't know yet, but I know it's over 0. You with me? And this dot down here is over, I don't know, up 0, isn't it? Because it's on the y-axis. Do you see that? Its height is 0. This dot and the dot up here is over 0. Everybody with me on that? We know whenever you're on a grid line, one of your numbers is 0, isn't it? Right? This is x, y, x, y. So in other words, when you're on the y-axis, your x is 0. Remember how it's opposite? When you're on the y-axis, your x is 0. When you're on the x-axis, your y is 0. When you're a dot on the x-axis, your y-coordinate is 0. Whenever you're on one of those grid lines, the opposite letter is 0. That's really important. Am I doing Charlie Brown? Wah, 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 wah? Or am I coming through? You got to get this. This will save you lots of time in the homework, lots of points on the exam. When you're on a grid line, the opposite letter is 0. Really important. So when you're on a grid line, the opposite letter is 0. So if you're on the y, the x is 0. If you're any dot, anywhere on that y-axis, your x-coordinate is 0. You're over 0 if you're on the y-axis, huh? And if you're on the x-axis, well, then you're up 0. Your y is 0. So if you're anywhere on one of those grid lines, if you're any dot on a grid line, your opposite letter is 0. Okay, so what? Well, that makes it a snap for us to find the coordinates. What do I mean? This one right here, first off, you got to identify which line is which line. Can you tell which one? There's two equations up there. This line, the lower down line, which is the one I'm working on right now, which equation is that? Look at how high up remember these numbers on the right are their height, their starting height, the first dot? The first one's at up 4, the second one's at up 8. Which one's this one? It's got to be up 4. It's lower than the other one. This has got to be up 4. This one's up here at 8, huh? How do I know? Well, because 4 and 8 are my only two choices. Those are my two lines. One of them's at 4, one of them's at 8. This one's got to be at 4. Good. So that one's by observation, right? Now, okay, great, I got that, but what about this one? Let's go over and kind of figure out what's up with this one. This one's over, I don't know, up 0. How do I find that one? Well, that one's the equation that has the 8 in it. It's this equation. Y, I'm just going to make it equals, because I'm just dealing with the line, by the way. See how I just took that less than or equal and made it equal? Why? Because I'm just dealing with the line. I don't care about the shading. I don't care about the less than, greater than. I just made it equal. I want to find a point on line. I want to find this dot right here. Remember, this is x, this is y. So I know y is 0. Put in y 0. Do you see that? If you put in y 0 in that equation here, let me bring it over here. It's running out of room here. If you put in y 0 in that equation, can you solve that for x? Right? Just jump that x over. Divide by -2. X is 4. This is 4, 0. We got our corners. Well, and then this one's 0, 0, obviously. We got our 4 corners. Now we're ready to plug them into the z thing at the top. Take the biggest one as the winner. I'm going to do that. But are we good to there? Does everybody see what happened? So what have I done so far? The subject to meaning controlled by, so subject to, I graphed the two lines, put them on my calculator, graphed them, shaded the inside because it said less. Less means shade below. In a minute they're going to say greater, we'll shade out there. And then find the 4 corners. This one's 0, 0. The intersection I found with my calculator. And then the other two I found by looking at the equation. One of them had to be up 4 by just looking. And the other one, I had to plug in y0 into the correct equation, though. And I solved for x. So we got the corners. Now that we have those corners, let me clear some space up here. We just plug them in. 4 corners. And really the 0, 0, no way it's going to be the answer. You can really skip that one if you want. So here we go. I'm going to plug into this thing. Z equals, can I move that up? Yeah, let me go even higher there. Z equals 6x plus 7y. So here we go. Item by item. One at a time. First one, doesn't matter what order, 0, 4. And I'll do him. And then 3, 2. There's a 3 there. 3, 2, do him. And then I'm going to do, what's that, 4, 0. Do him. Yeah, I'm not going to mess with 0, 0. It's not going to be 0, 0. So plug in 0, 4. This is x, this is y, huh? Plug in 6 times 0 plus 7 times 4. You see what I'm doing? I'm taking the z equals 6x plus 7y, the maximize. That's called the objective function, what your objective is. Real life problems in a few minutes, it's going to be like best way to maximize profit or best way to minimize cost in real life situation. So plug in the x and the y, the x and the y, the x and the y, and just calculate the 6x plus 7y and see who the winner is. So what do I get here? That'd be 28. Choose your calculator. 6 times 3 plus 7 times 2. Is that 18 and 14? 28, 30, is it 32? 32. And this one is 6 times 4 plus 7 times 0. What's that? 24. Who's the winner? Who's the biggest? It said max. Max. This one. 32, which we have a couple 32s, but at x3, remember this is x, this is y, x3, y2. That's not there. See, this is x2, y3. That's reverse. And this is x4, y3. That's not right. And these are the wrong maximums. It's none of the above. Is that what 11% of you knew, or did you just get lucky, you 11% who came up with E? Questions on that? Are we good? Want to try that? All right. These are the same every time. So if you can get one of them down, just the same thing, same thing, same thing. In fact, this is the hardest one. I'm doing the hardest one right now. See how the answers are already there and it's fractions? This is the only one with fraction answers. What's that? Oh, light. Yeah, so you can see. Huh? You can't hardly see, can you? All right. Let's try it. Want me to write a little bigger? Let's see. So this is what we start with, right? So 3x plus 4y greater than or equal to 21, 8x plus 4y greater than or equal to 32. So got to graph those two, right? Get y alone in both of them, put them into your calculator. So get y alone in both of them, put them into your calculator, hit the graph button. Hey, starting on Tuesday, we're going to do something special on the graphing calculator. You definitely need it. I'm going to actually infect your calculator with a bug. I'm going to take a little wire and hook up to your calculator and send you a program, is what I'm going to do, that'll allow you to do the homework. So you don't want to come on Tuesday without your TI-84 graphing calculator. If you don't have a TI-84, does everybody have a TI-84? Then I don't know if Miss Curtis still has them or the library, but that's the only one I have a program for, is the TI-84. So I'm going to give you a program which will make your homework a snap, and we're just going to hit the buttons. I mean, we're going to have to set up the words, but once we have it, we're just going to hit the buttons, rather than do it by hand. So make sure you bring on Tuesday your TI graphing calculator. All right, how you doing? Get y alone in both cases, right? So grab the 3x, jump it over, 4y greater than or equal to minus 3x plus 21, divide by 4, y greater than or equal to minus 3/4 x plus 21/4. That's ugly. And then the second one, jump the 8x over, 4y greater than or equal to negative 8x plus 32, divide by 4, y greater than or equal to minus 2x plus 8. Getting those two? Y alone, put them in your calculator. Put those both into your calculator, y1, y2. Hit the graph button. My same window works great. 0 to 10, 0 to 10. Got a beautiful picture. What's not going to show anything? Oops, that's the wrong button completely. That's the desktop. Where's the Elmo? There it is. Did it show anything? Nah, it never was. Oh, I guess it was okay. Huh? There, you getting something that looks like that? Kind of like the last one, huh? It's not. I could have guessed that. They all look like that. Sorta. Yeah, sorta. So that's the window 0, 10, 0, 10. So I'm going to go to fresh screen there. Let's got some room here. So one of them is like, yes, one of them starts lower, goes higher. It's kind of what you get every time. So, and keep them. So y greater than negative 3/4 x. So put it down here. 1/4. And y greater than negative 2x plus 8. All right, we all getting that okay? So now you've got to, where's the shading on this one? Is the shading the little inner zone or is it the outer zone? It's never going to be these in-between ones. It's all inner or all outer. Which one? Greater. Y greater. See that right from the beginning you could see that. Y greater. 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 That's out here. See what I mean by it's never the middle zones? That's the area greater than both lines. If you actually do the shading for both lines and find the overlap, that's what you would find, right? That's the zone above both lines, isn't it? So this one's the opposite. It's the greater. And see what they're trying to have us find the minimum. They want us to find the smallest among those greater regions, unlike the last problem, which was find the greatest among the lower regions. See, it's always going to be that way. But you can count on it. Basically, any minimized problem will have shading going out. And any maximized problem will have shading going in, because it's the reverse. All right, so now, what are the corners? Remember, it's always about the corners of that shaded region. Here, here, and here. Aren't those the corners of that shaded area? See how those are corners? Not edges, corners. Like something that could prick you or poke you. It's a corner, right? Do you guys see what I mean? Do you see how that's a shape? Would it help if I kind of focused it in for you? Like this? If I said, okay, look, I've got this shape here. Right? There's the shape. See how those three red parts are the corners of that shape. So I have to find those coordinates now and plug them into the z function and take the minimum, the lowest. That's the game plan. So how do you find those coordinates? How do you find the coordinates right here in the middle? Intersect on your calculator. So do the intersect thing on your calculator. I'm getting 2.2, 3.6. I'm having trouble seeing that. Thanks. 2.2, 3.6. Did you get that answer? 2.2, 3.6. Let's just keep working with decimals for now. We'll change them all to fractions when we need to later. 2.2, 3.6. Now, can you find the coordinates of the other two corners? The easy one's this one, the one that's on the y-axis. You can just look at the two equations. Oh, 21/4 might help you to change that. Isn't that 5.2? Just divide 21 divided by 4 is 5.2. So therefore, that means one of these dots is at a height of 5.2, and one of them is at a height of 8. You can tell which is which, huh? This must be 5. This must be 5.2. This must be 8. Because higher up, right? You with me? Did you catch that? Am I doing the Charlie Brown for you right now? Am I coming through, right? The number off to the right tells you where they hit the y-axis, doesn't it? It's the starting dot when you graph. Remember, you start at this dot up the middle that far, right? And then the other number is slope, rise and run. We're not really messing with that, right? The number off to the right. So therefore, I look at 12. The lower one's got to be the lower one, right? Got to be 5.2. The higher up one's got to be the higher one's got to be the 8, doesn't it? So what? Well, that means that this is the point over 0 up 8, isn't it? It's at up 8. Over 0 up 8. Okay, last one. Can you find this dot here? What his coordinates are? How do we find that dot and his coordinates? What we know, one of them is a 0. Whenever you're on a grid line, that's on a grid line, one of them is a 0. This is the x-axis grid line, so what coordinate is 0? The y, the opposite letter. Did y'all catch that? The opposite letter, the y is 0. So I want to find the x. When you're on the x-axis, your y is 0. When you're on the y-axis, see here on the y-axis, the x is 0, isn't it? The opposite letter is 0. So, okay, so what? Well, that means I'm going to plug 0 into the correct equation and solve for x. Which equation? This one that hits at 5.2. This one. Right? Just make it equals. We don't care about the greater than, less than, the shading, and we're all done with that. I'll just make this 5.2. It doesn't matter. Decimals probably easier. Just work with decimals, I would. And plug in what? Y is 0. Right? Y is 0. Into that equation. Everybody see how we find the dot on the flat line? We pick the right equation. We pick the right equation by noticing where it hits, 5.2, so it's the 5.2 equation, and you plug in y is 0, because you're at a height of 0 when you're on the flat line. So you plug in y equals 0, and then you solve for x. How do you solve for x? Jump the 5.2 over there, be minus 5.2 is minus 3/4 x. Good so far, because this is just 0 over here. Plugged in 0 for y, right? How do you finish solving for x there? I would, there's a lot of things you could do. I think it's best probably to do it one step. Multiply by the upside down. -4/3 on both sides. And it'll cancel all this stuff out, including the two negatives. And you get x alone. See what I did there? I'm multiplying both sides by -4/3. Everybody seeing that? To get x alone, when you've got -3/4 multiplying the x, multiplied by the reciprocal, the upside down, -4/3. Two negatives make positive. The 4s and 3s cancel, don't they? Or do to one side, do to the other. So just take your calculator now. Just take -4 divided by 3 times, that's times, isn't it? -5.2. Let's see what we get. 4 divided by 3. I'm getting 6.93333. So I'm getting 6.93333. Y'all getting that for x? Can we make that? Can you make that into a fraction?
Yeah, it's like 100.
Yeah, who cares? Just leave it a decimal. Yeah, it's something weird, huh? I would just leave it as a decimal. It's good enough. So that means this is I'll just say 6.93. Good enough. 6.93 comma 0. This is the hardest one. The rest will be whole numbers. It won't be decimals and fractions and stuff. So everybody's seeing how I'm finding this. I find the dot in the center by intersection on my calculator. Find the dot on the vertical axis by just looking at the numbers at the back of the equation, taking the bigger one. Find the number on the horizontal axis by plugging in 0 for y to the lower number equation. Solve for x. All right, so now that I have those three corners, I just plug them into the z. And I want the minimum this time. I want the low guy this time, not the high guy. So let's do that. If you're okay with that, I'm going to do that. So I'm going to minimize, what is it? Z equals 13x plus 9y. And the things are 0, 8. So 0, 8's one of them. And 2.2, 3.6 is the second one. And 6.930. All right. Plug them in one at a time. Here we go. This is x, this is y, this is x, this is y, this is x, this is y. So 13 times 0 plus 9 times 8, that's 72. And then 13 times 2.2 plus 9 times 3.6, I have no idea. 61, and then 13 times 6.93 plus 9 times 0. That's whatever 13 times 0.93 is. 90.09. All right, which answer do I want?
61.
This guy. Lowest. Minimum. Right, minimum. That's it. So the answer is this corner, this minimum value. They'll ask you for both. They'll say, what's the dots, the x, y for the corner, and what's the minimum value? And then we got to change these to fractions. So 2.2, 3.6. How do you change 2.2 and 3.6 into fractions? Well, you just put in your calculator, just type in 2.2 and hit math, enter. Do you know that? Hit math, hit the math button, which is on the left side, and hit enter twice. It'll change it to a fraction for you automatically. You'll get the answer 11/5. 3.6, same thing. Math, enter. You'll get whatever that is. I don't know. 18/5. So this becomes the point 11/5, 18/5, and 61 is the minimum. There we go. How we doing? Is that good? So everybody says a lot of steps, huh? It's going to be very much real life here in a minute. We'll get to some real life. Questions I can just run back over it again real quick. So what do you do? It's kind of the same thing every time. They give you two lines to graph. You graph them on your get y alone for both, graph them on your calculator, and then the shading greater, the shading's out. Find the corners. The middle corner is found by the intersection button. The corner on the left edge is the highest number on the right. Corner on the bottom, you got to plug in 0 for y to the correct equation and solve for x. Then you just plug those corners into the objective function, the z function. It's called the objective function, and find your find the lowest. So we get the right answer. There it is. The z is 61. Questions on that one?
Can we use a table for those corners?
What table is that?
On the calculator?
Oh yeah, that might be a good way to do it. Yeah, you sometimes they won't always hit the values, but sometimes it will. Yeah, yeah, good idea. Hit the second table, and yeah, you can just go to 0. You got to know which one you're looking for, huh? Yeah, it won't always show up there, but if you can do that, great. Feel free. Yeah, so you know what I'm saying? Sometimes you can hit second table and you can see that the x, you can always see the XY table, but it won't always hit right on 0. So it's not 100% reliable, but often it'll help.
What did you do?
So this was the answer that was minimum, right? Here is the corner that led to it. 2.2, 3.6?
Yeah.
So then I took 2.2, did math, enter on my calculator, got 11/5.
Oh, okay.
And then the 3.6, same thing, got 18/5.
Oh.
Yeah, just took that x and y and just converted them both to fractions. On that. Good. Other questions on that?